Hello, welcome to 10.1 Dilations. Go ahead and write this information off on the side. The last topic, topic 9, were rigid movements. Those rigid movements, we had 3 of them. The first one was to translate, which means to move a shape up, down, or side to side. We also had to reflect a shape, which is to flip a shape over a line, and revolve a shape, which is to turn a shape around a center point. Now we're going to be dilating shapes. That means that we're going to make them larger or smaller. As we are doing that, we're going to be basing that upon the scale factor. The scale factor is always going to be new over old, and that's going to be important to remember. So make sure that is written at the top of your paper. Scale factor means what the new shape is, how big it is compared to the old shape or the original. So a dilation is just making it the shape larger or smaller. Okay, so we're going to look and see which ones of these show a dilation. So the first one, this one is a translation. Translation here because we have shifted it from one place to another. This one right here is a dilation because we have enlarged it from this small shape right here to the large one. This one has changed the shape entirely. Over here we have this one, which it has been translated. This one has changed the shape entirely. And with that, we're going to go ahead and cross that out. This one has enlarged from that small black square to the larger blue square. So this one is a dilation. Okay, so we have several types of dilations, and these are pretty self-explanatory. The enlargements are getting larger, and the reductions are getting smaller. So as we're looking at them, once again, if you see this little prime sign, this sign right there, then we know that that's our new one. So knowing that it's our new one, we know that the black one is the original, that's the old one, and we know that this blue one is the new one. So this one must be an enlargement. This one over here, the second one, is going from this ABC, this black one right here, this is the old one, to this blue one. It is the new one. And you notice that this one is a reduction. And you notice that our scale factor is by a fraction. So reduction has a fraction for a scale factor, while a scale factor over here for the enlargement is going to be a scale factor of a number over 1. That's how you will know. Okay, for the given dilation, find the scale factor and then decide whether the dilation is an enlargement or a reduction. So we're going to actually find out if it is an enlargement or a reduction based upon which one is new and which one is old. This one is the old one. This one is the new one. The old one we have 1, 2, 3. And I told you that we were going to do new over old each time. So then let's go ahead and count how far it is from P prime to S prime. 1, 2, 3, 4, 5, 6. So we have a 6 over 3. We're going to divide that out. We have a scale factor of 2. And that makes it an enlargement. Over here we have new over old again. And the new one is this prime one. So we have 2, 4, and we have 2, 4, 6, 8. So it is a scale factor of a half. And so we know it is a reduction because we have a scale factor that is a half, which means it's getting smaller. So looking from our old one to our new one, it has gotten smaller, which makes it a reduction. Where the first one over here we have going from our small to our bigger one, so it makes it an enlargement. Okay, so part 3, they're going to explain how we're going to use our scale factors to go ahead and get our new coordinates. So when we are looking at A, it starts out at 3, 6, and we have a scale factor of 2/3. So I'm going to take the 3 and I'm going to multiply it by the 2/3, which remember, we're just going to multiply going straight across, and then we're going to reduce it down. So that first one is 2. Then we're going to take the y coordinate, which is 6/1, times 2/3, multiply going straight across. 6 times 2 is 12 over 3, which is 4. So this is going to be a prime. So I'm going to take the coordinates for a, that x number, multiply it by 2/3, and then my y number, multiply it by 2/3. I'm going to do the same thing for b and for c and get these answers. Okay, let's go ahead and do one together. Okay. Let's start with a. We have a point of 1, 2. And we are going to have a dilation around the center of 0, 0, which is what we're going to be doing today, a scale factor of 3. Because I have a scale factor of 3, I'm going to take each of my x and my y and I'm going to multiply it by 3. When I do that, I'm going to do 1 times 3, which is 3, and 3 times 2, which is 6. So this is going to be a prime. Okay. Next is b, and b has the coordinates of -2, 1. A scale factor of 3, so I'm going to multiply each one by 3. So -2 times 3 is -6, and 3 times 1 is 3. So this is going to be b prime. C has a scale factor, or has a ordered pair of -1, -1. I'm going to multiply that by 3, and I'm going to get -3, -3 for C prime. Then it says go ahead and use this, and let's get it graphed. Okay, so A was at 1, 2, so over 1 up 2, that was A. And then A prime is over 3 and up 6. 1, 2, 3, 4, 5. Oh, that's slightly off my graph. 6, that's A prime. Then I'm going to do B, which is -2, +1, and B prime, which is -6, +3. B prime, and then let's do C. C is -1, -1, and C prime is -3, -3. So we should be able to go ahead and make our lines for each one of those. So this is my first triangle, and this is my second triangle. And you can see it is substantially larger, like 3 times larger, which is what the scale factor does to it. Okay, our last one says that we have these vertices and we have triangle MNO, which is the image after the dilation because these were all primes, with a center of 0, 0 and a scale factor of 3/4. And we want to know what the coordinates of M are. So let's go ahead and find that. The coordinates of M started out to be 8, 4. And we said that we have a scale factor of 3/4. So we're going to multiply it by 3/4. Well, because this is a little bit harder, I'm going to go ahead and show you the work on the side. So I have 8 times 3/4. And once again, we're going to put the 1 under the 8, and then we're going to multiply going straight across because that's how we multiply fractions. So 8 times 3 is 24. 1 times 4 is 4. When I divide this out or reduce it, I'm going to get 6. So that's my first coordinate. My second coordinate, I have 4, which is my y coordinate right here. I'm going to multiply that times 3/4. I'm going to put the 4 over the 1 to make it into a fraction. Multiply going straight across. 4 times 3 is 12. 4 times 1 is 4. Reduce that down, and I'm going to get 3. So my new coordinates of m are going to be 6, 3, and that is m prime. We can go ahead and we can do n as well. They haven't asked for that, but let's go ahead and do that just so we make sure that we know how. So we have 4, -4. I'm going to multiply both of those by 3/4. The 4 over 1 times 3/4. That's going to be 12 over 4, which is 3. And then I'm going to do the same thing with a -4. Well, of course, I'm going to get the same answer, but it will be negative instead. So I'm going to have 3 -3 for n prime. And then the last one says that O is 0, 0. Because O is 0, 0, then I'm going to have 0 times 3/4, which is still just going to be 0. So this one, this Q prime, or O, is going to be O prime, and that's still going to remain 0, 0. So here I have all 3 of my primes. Okay, you're going to go ahead and get started on your homework. Please let me know if you have any questions. Thank you so much. Have a good day.